What's up, everybody? I got another crazy hard hat talk for you all. I wanted to do a video talking about conduit bending tips. So, kind of just wanted to briefly go over the book method and just sort of give a sort of background to it in case you were curious about the multipliers for offsets. So, just to begin with this, you look at a bender shoe or you hear somebody say the multiplier and you might be curious, like, what is that? Like, how do you get this? So it all goes back to high school, which is kind of funny, with Pythagorean theorem and SOHCAHTOA. And if you didn't think you're going to use that again, you'd be kind of surprised that it is a very frequent thing that gets used in electrical. So, if you remember, sine opposite hypotenuse, cosine adjacent hypotenuse, and then tangent opposite over adjacent, those are the things. But primarily what we're going to be dealing with is in reference to what's helpful to us. So we make a lot of offsets where we have a change in direction, and then we go back to the same plane that we started at. And when you look at that shape, if you imagine a triangle, right, a hypotenuse would be created on the diagonal portion of your offset. So not the two parts of your offset that are straight, but on the diagonal part. So that's your hypotenuse of a triangle, basically. So if you're able to find the length of that hypotenuse, you have your distance between bends. So that's why the distance between bends formula is the distance multiplier times your offset rise, and then you add for shrink. So if you're wondering, like, how do these numbers come about? Are they just crazy? Like, how does it go? It's SOHCAHTOA. So if you set it up with SOHCAHTOA, it's sine of theta, where your bend angle. So in this case, it's going to be our common bend angles that we all use as electricians, starting at 10 degrees, 22 and a half, 30, 45, 60, and 90. Not that you're going to be using anything for that, but those are your bend angles that you're going to be using. So if you set up an equation, let's say we have a 15-inch obstruction, and we're trying to get right above it, so 15 inches, right? If we do sine, let's say, we have a decent amount of space to form this bend. So if we just choose a 30-degree bend, it's not too steep, it's easier to pull through. So let's just go with that. Why not? So the sine of 30, if you put that into your calculator, is 0.5. So if you go and do that, and then you multiply the sine of 30 by the hypotenuse, and then you multiply the other side by the hypotenuse, you're going to be given an equation where you need to divide sine of 30, or 0.5, and you're going to get 15 divided by 0.5, which means that basically all you have to do is multiply by 2. And everybody knows that the multiplier for a 30-degree bend is 2. So that is where that comes from, and so you can do that. It's always going to be sine in our case because we have two knowns, right? We know our bend angle. That's something that we determine. It's usually based off the space that's available to you. Like if you have a stick of conduit that ends like really close to the thing you're trying to hop up and over, you usually have to consider a much more steep bend angle. And if you're like pretty far back and you want to make the pull real nice, super smooth and easy, you can go with a 10. So that's like where that comes from. So dividing by 0.5 for in the case of a 30-degree bend angle is where the multiplier of 2 comes from. Because multiplying by 2 is the same thing as dividing by a half. So that's where that comes from. And then your shrink constants are determined known values that the pipe does shrink by when you bend them at that angle. So that's why they have different ones per the angle. So that's like the background behind that. I've known some people that haven't got that, which is, understandable. Like, textbooks are not that great, but that's where that comes from. So moving on, if don't feel comfortable doing, like you don't want to have to tweak a bend or something, and you want to just get like within half an inch or just like straight up, straight on with your offsets, and you don't want to do math, still thinking about a triangle, right? So you are the one who decides the bend angle for your offset. You just basically, what you do is you say, hey, do I have a lot of space to do this? Do I not have a lot of space to do this? So once you do that, just go ahead and bend. You know the bend angle that you want to do, and you know how far off you want to start that. So do that. So that's a simple thing that I've done, like when it's like I've come up to an obstruction and I'm like, okay, I don't really want to do the math on this right now. I don't want to do 1.41 and then for a 45-degree angle, and then add my 16th of an inch shrink per inch of offset. Like, I don't want to do that right now. One, I don't really like having my phone out because people say stupid stuff all the time, and it's just like, whatever. So a technique that I would recommend is that you just bend where you want to start the offset, right? Bend it to that angle. Then put it in the same plane as the floor. So make sure that it's sitting level on the floor. It's not like angling down or something. You don't have it like sitting flat. Just make sure it's sitting flat. You put your foot down sometimes. And then with that there, put your tape measure to the floor, and with the part of the offset that's angling up, take your tape measure and just find out where, say, 15 inches is. Or say, like, I typically do it with really big offsets, like if I have like a 60-inch offset, like I'll do this all the time. And then I write down those measurements if I'm ever doing something in a big pack, and so that my bends are replicatable. So I just wanted to show that tip. And then, so once you get that height, because you know what offset height you need, then you just bend on center on that mark that you did. So if it was 15 inches and you have the pipe sitting like this, and you mark 15 inches, say it's over here, then you just mark the, around the pipe if you want to, or if you know the plane that it's going to be in, where you're going to be looking at it on the bender, then you can go ahead and just, mark it in that one place. But then once you have that, right, just bend on center on that angle, and that's basically like you did like a reverse of SOHCAHTOA by just saying like, okay, I know that if I do this, and then if I come up my offset rise, then I'll get my desired hypotenuse length just by eyeballing it, kind of. So it's something that I have used when I really don't want to do math, and so I hope that helps. Some other tips that I have, which aren't as important, but I think are helpful, is just familiarizing yourself with when conduit is going to kink, and when conduit is, and what you can do to prevent that. So you're not supposed to install conduit that is kinked or has ripples in it, because it can create a sharp edge in the inside. No one can see on the inside of the pipe, so you don't really know what's happening there. When it crumples, is it making a sharp edge? Is it going to destroy the insulation on the conductors? You don't really know. So if you kink a pipe, it's kind of ruined. And so to that point, one of the reasons that they say when you're bending a 90-degree bend that you're supposed to bend with heavy foot pressure is the fact that, your body weight is going to, if you're pressing pretty consistently, is going to make like it's going to allow for an almost like hydraulic bender or electric bender amount of force. And so if you notice, like, you hardly ever crumple your 90s, right? But if you do an offset at 60 degrees in the air, it crumples like relatively frequently. Like, you got to be careful. So, or not relatively frequently, but you have to be careful to work around that. So, another tip that I would have is that if you have, like, let's say you did an offset and you kind of winged it, certain amount of times that you can put that bender around that conduit again and bend it before your pipe starts to crumple. So just keep that in mind. You only have maybe about one or maybe two more adjustments that you can make before your pipe is gonna start to kink, and you don't want that. So just as a tip, if you have to put the conduit back in the bender more than once, your chances of crumpling the pipe are much higher. So getting really good at getting your bends accurate is going to make it so there's no boneyard that you have lying around. And so let's see, in that same vein, right, a 45-degree bend crumples more frequently than a 30, and a 60-degree bend crumples a lot more often than a 45. So my advice to you is, if you can, just bend on the floor. Bend on the floor and do it in one solid fluid motion if you can. So with heavy foot pressure, that would be my best advice that I can give for bending kicks and offsets without crumpling conduit. So that would be ideal, but I bend in the air a lot. I guess it just has to do with the fact that I'm not a fan of, I feel like it takes more time sometimes, and so I wanted to be able to perfect bending in the air more, because I'm more of a fan of staying in a position that's a little quicker, and so that is more like a high risk. If you pull it off, you did save some time, but if you don't do it right and you keep bending in the air and you're trying to bend 60s in the air, you're more than likely not gonna get it. It's not gonna go too well. So so my advice would be to, in that same vein of keeping heavy foot pressure, keep your hands close to the bender shoe and put a lot of weight, throw your weight behind it when you do it, and do it in one fluid motion. Don't do it once and then realize that you gotta go a little bit more because there's spring back on the pipe. You gotta be able to anticipate when a conduit is going to crumple, and so that's just something to take into account. So I guess my last thing that I want to touch on is that the size of the bender shoe affects bending conduit. So, and also the multipliers, I use them to help me determine if a bend is going to be possible. So for one thing, the reason that you might consider doing a more shallow bend is the fact that it's going to be easier to pull your wire through, down the line. So that is a consideration to use. It also makes it easier for you for the fact that if you get close to 360 degrees of bends, you have to set a box. So that's something that you use to plan your route. But what I don't always see people using to plan things is to consider the math of, okay, if I need this much space to form this bend, that's going to determine the bend that I need to use. So instead of being I'll start it at a 30 and then I'll move up to a 45 if I need to, although that can be a smart move if you're bending and there's nothing to get a hard measurement off of, so you're just I think that looks like a 30, or you do the trick with your folding ruler if you're a real cool guy and you're oh, this is a 30-degree bend, or I have my folding ruler, and if I go it out at this angle, then, and if I go out like this and then I come back down, it shows that a 30-degree bend would be best for this. And I feel I've gotten better at understanding what a 45-degree bend looks like by eyeballing it, but just so people can understand, for instance, if I have to do a 10-inch offset, right, and I have to do it, it has to fully form, let's let's say the stick of pipe is really close to the obstruction and I don't want to cut the pipe, you know, I'm going to do whatever is the simplest. I don't want to have to make more cuts. So I'm just going to do what I can do going forward to accommodate the situation. So, you know, in that situation, I'm going to use, you know, maybe a 45. And I have to think, like, if I do a 45, for instance, I'm not going to do a back-to-back 45 if my, like, offset is, like, let's say we're bending with 3/4 inch pipe, right? Bending with 3/4 inch pipe, and the bender shoe size takes up about 4.5 to 5 inches of space when you go ahead and you actually put the conduit in the shoe. So like before you can start to do your 45 or your 30, you need about like 5.5, 6 inches of pipe before you can like even consider doing your bend, right? So like some people will be like, oh, to do a stub 90, just give me like a stub 90 from a 3/4 inch pipe at 6 inches. But like sometimes you can't, like especially with 1 inch, like you cannot achieve an 8-inch stub. Like you have to cut it down afterwards because the arrow does not even start for like almost like 1 inch to 2 inches on the bender shoe. So because of that, it's like it's physically impossible to do the stub 90. So you have to cut it down afterwards, and hopefully you can still throw a connector on there and have it be straight on that conduit. So that's just something to consider. Like if the bender shoe makes it impossible for you to form a bend, don't consider doing it, because you're going to be basically doing a back-to-back 90, where you're going to or your bender shoe like size is going to start affecting the other bend and like taking bend out by doing the next bend, because there's not enough space for the conduit to like not be bent and affect the other bend. So so those are some things. Like think about the bender shoe size. Bending 1 inch is not the same as bending 3/4, and you can do things bending 1/2 inch that you can't even consider doing with 1 inch. 1 1/4 hand bending, sometimes you cannot even consider doing a 90 depending on the temperature. Like I weigh like 210 pounds, and I cannot do a fluid motion bend with 90s on 1 1/4. Like I cannot do it without kinking the pipe. I've never been able to do it. I feel like I always get like a strange aluminum conduit with 1 1/4, and it always crumples no matter what. Like I'm not like a particularly like light guy, and I cannot do it. So I always like, if I think I'm gonna crumple it, I'll instead of being like, well, you know, it's got to be perfect, you know, and just keep slamming, trying to do it one way. Like instead of just crumpling like 3 full sticks of conduit, like I'm gonna change how I do it. I'm gonna like start it. I'm gonna bend it to like a 45, and then I'm gonna work the bender back, and then I'm gonna like make it so that the radius of the 90 is gonna be larger, but I'm not gonna crumple that pipe. And so that can be hard to replicate, but you got to do what you got to do in order to make it an actual install that's worthy of being installed. You don't want to throw something up and it's like hanging on by a thread that it's like existing. Like you don't ever want to go back to something. You don't want to like maybe pass or maybe, you know, get past someone's scrutiny on something. Like it looks good and it got installed. Like that's like the sort of quality control that you want for yourself. That's like the sort of like prerequisite that you should have before you consider even installing something. Because if you're just going around and you're like just installing really shoddy work, like it's not just like you're not doing it right. Like it's like literally you could have really negative side effects, like ripping the insulation off of a conductor, or you know, the conduit fill has been now affected by the fact that you crumpled the pipe and made it smaller to pull through. So just like some things to consider. I could definitely make a full-on video about this, about conduit bending. There's so many different things. But yeah, I hope you guys found this useful. I will catch you all in the next one. And let me know if there's any other videos that you would like to see. I'll catch you all later. Bye.